Alright, so this is just to help anyone who, for whatever reason, can't access the simulation. I'm going to do a walkthrough of the steps so that you can see what would happen if you were able to do this yourself, and I will walk through the steps so that you can gather the data that you need to complete the worksheet. Then I will leave the calculations up to you, and then I'll go through, probably in a separate video, some of the follow-up questions just with some hints. Again, not exactly an answer key, but just to help you along with some of these questions. So here we go. We're going to start up the simulation. Okay, so there are a few things to see here. We have solute amount, okay, moles. The number of moles goes from none to lots. The volume in liters, right, goes up and down. That's the amount of solution. And as you can see on the other side here, the molarity, the concentration, changes in a couple different ways. If I increase the water, or the volume of the solution, you can see that the concentration goes down. I'm diluting the solution by adding more solvent, more water. If I leave the volume there, but decrease the amount of solute, or the amount of stuff in there, the molarity goes down. So by increasing the volume or decreasing the amount of solute, I can lower the concentration. And going in the other direction, if I leave the solute the same but decrease, right, so now I'm making it more concentrated by having the same amount of stuff in a smaller volume of solution, that increases the concentration. Or if I leave the volume the same but start adding more solution, the concentration will go up. Okay, so there's different ways having to do with because the volume and the amount of solute are both directly related to the concentration. Okay, so in the simulation and on the worksheet, it says determine which solutions can become saturated by adjusting the number of moles and the volume of solution. So as we just saw, we can change the amount of solution, we can change the amount of moles. So to get saturated, you want to have the highest concentration, so a concentration that can't get any higher. That's what saturation essentially means. You've dissolved as much stuff as you can in a given amount of solution, so that's the saturation point. So the conditions that would be most likely to give you a saturated solution are a low volume of solution and a high concentration. Okay, so how do we figure that out? Well, if we look at the solution values, here's the molarity over here. It tells you what the molarity is. Okay, so if I increase or decrease the amount of solute, you can see that number goes up and down. And if I increase or decrease the volume, the number goes up and down. Now, here's what I don't know. I don't know the saturation point, okay, for the drink mix, okay, because according to the numbers, right, this is going up, 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 and we get to 5, and we can't go any higher given these conditions. So 1 mole of solute in a fifth, 0.2 liters, right? 1 mole for every 0.2 liters. If you do that math, which I think is probably one of the problems on the next page, you get a concentration of 5 molar. But that's not saturated. We haven't reached the limit of what we can put in here. So now I'm going to put everything starts out at 0.5, right? Reset. So now let's try the next one, which is cobalt 2 nitrate. And if I decrease the volume and increase, okay, again, I've gotten to 5 molar, and I can't adjust these concentration values any further, so that's not saturated. Let's reset. Cobalt 2 chloride. So this is a different compound. Lower it, raise it. Oh, okay, so this is the first time see we've reached this line here and it says saturated, and if I add more, if you look in the beaker here, you see those are supposed to be little crystals showing up. And what that means is once I hit this point of saturation, any more cobalt chloride that I add in here won't dissolve, because I've saturated the solution. I have put as much stuff in there as it can handle, and adding more won't affect the concentration. What's really happening is that one of these grains, for example, just to make it simple, one of these grains is actually dissolving, and at the same time another crystal is precipitating or forming. So it's not that nothing's happening, but stuff is dissolving and stuff is crystallizing at the same rate. So the overall amount of stuff doesn't change. So it's like on a treadmill. Okay. Okay, so this one can be, so let's show the values because you need to fill in this table. Okay, so this one can become saturated, and it becomes saturated at this point. Okay, there's the saturation. So these are the numbers that you want to write in the box on the sheet. Okay, you've got 0.876 moles in 0.2 liters. Okay, and you can do the calculation of what the molarity is. It's actually here, right? So 0.876 moles divided by 0.2 liters rather, is 4.35 molar. That is the highest concentration we can get at what is presumably a certain temperature and pressure, because those are the conditions. Okay, so let's move on to the next one, which is potassium dichromate. Whoa, this one's already saturated at the starting point. So let's go down. Let's lower the molarity. Let's see if we can get it to go. Oh, okay. So here is the point at which it becomes saturated. Okay, 0.25 moles in 0.5 liters. Okay, so under the box on the worksheet, you're going to fill in 0.247 moles and 0.5 liters, and when you do that math out, you get 0.5 molar is what it really comes out to. When you, it's just that we can't, because of the way the slider works, we can't get it exactly there. Okay, so next one, gold chloride. Okay, so it's not saturated yet, but we can see from the little bar over here that we're going to be able to get it concentrated. So let's try increasing the number of moles. And we've got the maximum number of moles. Let's change put the values on here. So we're at 1 mole and a half a liter, which is a 2 molar solution, 1 over 0.5. So we've put as much solute in as we can with the conditions we have. So the way to increase, remember, the way to increase the concentration, other than adding solute, is lowering the amount of solution. So let's bring this down, and it's going to hit the saturation point right about here. Okay, 1 mole in 0.444 liters. 1 over 0.444 is 2.25 molar. That's the saturation point under these conditions. Okay. So what do we have left? We have potassium chromate. And you can see from the bar here that we're going to be able to concentrate this to saturation, increase the solute. That doesn't get us there, but if we combine that with a reduction, right? That's there's a cooking term, reduction, right? Which just means it's actually this. You're concentrating something. You take a the one that I see used is a balsamic vinegar reduction, right? So balsamic vinegar is a specific type of acid in a solution, which is water. And so if you slowly heat that up, the water will go away, and the vinegar becomes more concentrated to a point where it's almost like a sauce that you can add to stuff. So you hear that, well, you reduce this down, and what that means is you cook away some of the water, which makes the remaining stuff more concentrated. So we get to saturation. Let's see what the values are. Okay, it's 1 mole, right? That's always the max we can do over here. And then we lowered this down to 0.298, or possibly, you know, 0.3. Right? It's right as you cross that 0.3 line that you get to saturation. So the molarity, the maximum molarity is 3.35 molar. And no matter what I do, right? So I can't make that concentration any higher, even though I could lower the amount of solvent and make it a smaller volume. But you can see as soon as I get below that saturation point here, the crystals just start to form. So we reset. A couple more to do here. Nickel chloride. If I lower the volume and increase it gets to the top, 5 molar, not saturated. So the saturation point is somewhere above 5 molar. Copper sulfate, we're definitely going to be able to saturate this one, so let's show the numbers. If I start adding solvent, or solute rather, I get to saturation right about 1.4. Okay, so you see it's below 1.4, it gets to 1.4, and then no matter what I do over here on the left, that number doesn't get any higher, okay, because the amount of stuff that's dissolved isn't changing. Even though I can add more, and again, this is if you've made, especially when you're younger, if you make Gatorade or lemonade like from the powder, your first instinct is to just dump it all in because it's sweet and you want it to be as sweet as possible. Well, once you get to a certain point, you can add as much more mix in as you want. It's not going to dissolve, it's just going to sit there in a pile on the bottom, like that's what this is showing here. So the saturation point here is 0.7 moles in 0.5 liters, which if you divide those out, you get 1.4 molar. That's the saturation point. Okay, and then potassium permanganate. Whoa, this is, hold on, reset. Potassium permanganate. This one's already saturated at the starting condition, so we're going to need to find what that point is. The saturation point here is 0.5 molar. So that means that there's half a mole per liter. This is half a mole in half a liter. So if I increase the volume, bingo, there's my saturation point. It's right there. 0.5 molar means half a mole in 1 liter. That's what it means. 0.5 moles per liter. So just to show you really quickly, again, the relationship here, what I did, because I think it makes it very clear, is 0.5 moles in a liter is 0.5 molar. However, I could have also said 0.25 moles in half a liter, right? That's the same ratio, and you can see where it hits the 0.5 molar mark. 0.25 divided by 0.5 is 0.5 molar. Okay, if I lower the concentration now, it becomes saturated. If I increase the amount, it becomes saturated. So these two things are connected. Alright, so there's the numbers that you need for the first table in your worksheet. And then you have to come up with the definitions. Okay, I'm going to let you take care of those. Make sure when you're looking up things like saturated and unsaturated, that it's in reference to solutions in science and chemistry, and not, there's lots of other definitions of saturated. I mean, they all mean the same thing, but there's a saturation of advertising, for example. They use the term in different ways, but just make sure you get one that's related to solutions in chemistry. Solution, solvent, solute, those should all be pretty good. And then I'll post another video here in just a minute with some helpful hints on the problems on the back page. There you go.